Imagine a clock, not an ordinary clock ticking on your wall, but a cosmic clock counting down the end of everything. Every star, every galaxy, every atom, even time itself. For most of human history, people believed the universe would last forever, but modern scientists studying cosmology have discovered something shocking. The universe has an end expiration date, and according to current calculations, scientists may already know how it will end. Tonight, we are going to explore the terrifying future of the cosmos, a journey trillions, quintillions, even Google years into the future, where stars die, galaxies disappear, and the universe slowly fades into darkness. Asterisk, the beginning of the clock. To understand how the universe ends, we must first go back to its beginning, about 13.8 billion years ago. Something extraordinary happened. The universe suddenly exploded into existence in an event known as the Big Bang Theory. Space expanded. Time began. Energy transformed into matter. In the first seconds, the universe was hotter than the center of any star. Particles formed, atoms emerged. Eventually, gravity pulled matter together, forming the first stars and galaxies. And over billions of years, the universe grew into the magnificent cosmic web we see today. But something strange was happening. Universe wasn't just expanding. It was accelerating. Something mysterious was pushing galaxies apart faster and faster. Scientists later named this mysterious force dark energy. And this discovery changed everything. Because the fate of the universe depends on it. Asterisk, the expanding universe. In 1929, astronomer Edwin Hubble made a discovery that shocked the world. Using powerful telescopes, he observed that distant galaxies were moving away from us. The farther the galaxy, the faster it was moving away. This observation became known as Hubble's law. It proved something incredible. Space itself was stretching. Imagine dots on the surface of a balloon. As the balloon inflates, every dot moves away from the others. That is exactly what is happening to the universe. But decades later, scientists made an even more shocking discovery. Using distant exploding stars called Type Ia supernova, they found the expansion was speeding up, not slowing down. Something invisible was accelerating the entire cosmos. That mysterious force is dark energy. And it may determine how the universe dies. Asterisk, the first stage of the end. Right now, the universe is full of galaxies. One of them is our home, the Milky Way, containing hundreds of billions of stars. But in about 4 billion years, something dramatic will happen. Our galaxy will collide with our nearest neighbor, the Andromeda Galaxy. This enormous cosmic collision will reshape both galaxies. Stars will be flung across space. New stars will ignite. And eventually, the two galaxies will merge into a giant new galaxy, sometimes called Milkomeda. But even this spectacular event is only the beginning of the universe's slow decline, because star formation is already slowing down. Astronomers studying distant galaxies have discovered something alarming. The universe is running out of the gas needed to form new stars. Meaning the cosmos is slowly entering what scientists call the stelliferous era's final phase. The age of stars is ending. Asterisk, Over the next 100 trillion years, the universe will grow darker. Star formation will almost completely stop. The only stars still shining will be small, long-lasting stars known as red dwarf star. These stars burn extremely slowly. Some may live for 10 trillion years. But even they will eventually die. When the last red dwarf finally fades, the universe will enter a new era, the degenerate era. Asterisk, the age of cosmic corpses. In this era, no new stars will exist. The universe will be filled only with stellar remnants, white dwarfs, neutron stars, black holes. White dwarfs are the burned-out cores of stars like our sun. Neutron stars are incredibly dense objects where atoms have collapsed, and black holes, the darkest objects in existence, regions where gravity becomes so powerful that nothing can escape, not even light. Black holes slowly grow by consuming matter around them. But surprisingly, even black holes are not eternal. In 1974, physicist Stephen Hawking made a revolutionary discovery. Black holes slowly evaporate through a quantum process called Hawking radiation. This means that given enough time, even black holes will disappear, but that process takes an almost unimaginable amount of time. The largest black holes may survive for 10 years. That number is so large it is called a GOOGOL. Asterisk, the final darkness after a googol years. The last black hole will evaporate. And the universe will enter its final stage. Future scientists call the heat death of the universe. In this future, no stars exist, no galaxies remain, no light shines anywhere. Matter itself slowly decays, atoms fall apart, the universe becomes an endless, cold, empty void. Temperature approaches absolute zero. Nothing moves, nothing happens. The cosmic clock finally stops. The universe doesn't explode. It doesn't collapse. It simply fades away. Forever. Asterisk, but some physicists believe the end of the universe might be even more terrifying. According to quantum physics, the universe could suddenly collapse into a more stable state through something called false vacuum decay. If this happened, a bubble of new physics would expand at the speed of light, destroying everything in its path. Atoms, stars, galaxies, even the laws of physics. And the worst part? We would never see it coming. Asterisk, so scientists may know how the universe could end. But one mystery remains. Is this truly the final ending? Or could something happen after the end of the universe? Some theories suggest the cosmos may restart in another Big Bang. Others propose our universe is just one bubble in a vast multiverse. Meaning the death of our universe might simply be the birth of another asterisk. The universe has existed for 13.8 billion years, but compared to its possible future, we are living at the very beginning of the cosmic story, a tiny moment, in a universe that will slowly drift into eternal darkness. And the real question is not when the universe ends. The real question is why it existed at all. The slow death of galaxies billions of years from now, the universe will look very different from today. Right now, the night sky is filled with countless stars. Entire galaxies glow like islands of light in a vast ocean of darkness. But this beautiful cosmic scenery will not last forever because the universe is expanding. And the engine behind this expansion is something scientists still struggle to understand: dark energy. Observations from telescopes such as the Hubble Space Telescope and the James Webb Space Telescope confirm that galaxies are drifting farther apart every second. Imagine standing on a lonely island in an ocean where every other island is slowly moving away. At first, the movement is barely noticeable, but over billions of years, those islands disappear beyond the horizon. That is exactly what will happen to galaxies. Eventually, distant galaxies will move so far away that their light will never reach us again. Future astronomers living trillions of years from now may look into the sky and see nothing. No distant galaxies. No evidence of the expanding universe. Only the stars within their own galaxy. The vast cosmic structure we see today will become invisible. And the universe will grow lonelier with time. The end of the stellar era. We currently live in what cosmologists call the stelliferous era. This is the era of stars. Stars form from enormous clouds of hydrogen gas. Gravity pulls these clouds together until nuclear fusion ignites, producing light and heat. Our own sun is one such star. It has been shining for about 4.6 billion years, and it will continue shining for another 5 billion years. But stars cannot live forever. Eventually they run out of nuclear fuel. Massive stars explode as supernova. Smaller stars slowly fade into white dwarfs. Over trillions of years, star formation across the universe will gradually stop. This is because the hydrogen gas needed to create stars will slowly run out. Galaxies will become graveyards of ancient stars. Eventually, the last new star will be born. After that moment, the universe will never produce another star again. The night sky will slowly darken as ancient stars die one by one. The universe began with a burst of unimaginable energy. Stars ignited. Galaxies formed. Planets emerged. Life appeared. And somehow, consciousness arose to look back at the cosmos that created it. But according to our best scientific understanding, this magnificent universe may not last forever. One day the stars will fade. The galaxies will disappear, and the universe will become silent. Cold. And dark. Yet the greatest mystery remains unsolved. Why did the universe exist at all? And why did it create beings capable of asking that question? Perhaps the most extraordinary thing about the universe is not how it will end, but that for a brief moment in cosmic history, it allowed us to witness it. When galaxies become invisible billions of years in the future, the universe will look very different from what we see today. Right now, powerful observatories like the James Webb Space Telescope allow astronomers to see galaxies billions of light years away. The night sky is full of cosmic islands of light, but because the universe is expanding faster and faster due to dark energy, most galaxies will eventually disappear beyond our observable horizon. Imagine standing on a beach watching ships sail away across the ocean. At first you can see them clearly. Then they become tiny dots. Eventually they vanish beyond the horizon. In the distant future, galaxies will disappear. In exactly the same way, their light will stretch and fade as space expands. Future astronomers may live in a universe where only one galaxy is visible, their own. The entire cosmic web that we see today will become invisible forever. The slow cooling of the cosmos. Today, the universe still has a faint glow left over from its birth. This ancient light is called the cosmic microwave background. It is the oldest light we can observe, a snapshot of the universe when it was only 380,000 years old. But even this relic of the Big Bang will eventually fade. As the universe expands, the wavelength of this radiation stretches. Over trillions of years, it will become so weak that it can no longer be detected. Future civilizations might never know the universe had a beginning. The evidence will simply disappear. The era of lonely black holes. After stars and galaxies fade away, black holes will dominate the universe. Some of these black holes are incredibly massive. At the centers of galaxies lie giants, millions or billions of times heavier than the sun. One of the most famous examples is Sagittarius, but even larger ones exist across the cosmos. These objects are so powerful that they can swallow entire stars. For trillions of years, black holes will wander through the darkness of space. Occasionally, two black holes may collide. When they merge, they release enormous bursts of gravitational waves. These waves ripple through space-time itself. But eventually, even these titanic objects will begin to shrink. Because of Hawking radiation, discovered by Stephen Hawking, black holes slowly lose energy. Over unimaginable timescales, they will evaporate. The last flash of light, when a black hole finally evaporates, it does not simply fade away quietly. Instead, during its final moments, it may release a burst of radiation, a brief flash of energy marking the death of one of the universe's darkest objects. Imagine the final black hole in existence, floating alone in a completely dark universe. No stars, no galaxies, nothing but emptiness. And then, after trillions upon trillions of years, it vanishes in a final flash. After that moment, the universe enters its most silent era. At this point, the cosmos becomes almost completely empty. Only scattered particles remain drifting through the vast darkness. The universe approaches the state scientists call heat death of the universe. Temperature approaches absolute zero. Energy becomes evenly distributed across space. Nothing interesting can happen anymore. No stars will ever ignite again. No new galaxies will form. The universe becomes a place where change is nearly impossible. It is the ultimate cosmic stillness. The strange fate of space itself. But the story might not end there. Some physicists believe that even space itself may not be stable. Quantum theory suggests that empty space is not truly empty. Instead, it is filled with tiny fluctuations of energy. This idea leads to a frightening possibility called false vacuum decay. If our universe exists in a temporary vacuum state, it could suddenly collapse into a more stable one. When that happens, a bubble of new physics would appear. This bubble would expand at the speed of light. Everything inside it would be destroyed instantly. Atoms would cease to exist. The fundamental forces of nature might change. The universe would end in a sudden and unstoppable transformation. And because the bubble travels at light speed, no one would ever see it coming. The possibility of infinite universes. Despite all these predictions, scientists still face a profound mystery. Is our universe the only one? Or could there be many universes beyond our own? Some cosmological theories suggest the existence of a multiverse. In this view, our universe might be just one bubble in a vast cosmic ocean. Other universes may have different laws of physics, different numbers of dimensions. Some might collapse quickly. Others might expand forever. If the multiverse exists, then the end of our universe would not be the end of reality. It would simply be the end of our particular cosmic bubble. A cosmic perspective. When we think about the immense timeline of the universe, something extraordinary becomes clear. Human civilization has existed for only a few thousand years. Modern science is only a few centuries old, yet we have already begun to understand the fate of the entire cosmos. Tiny beings on a small planet orbiting a typical star inside the Milky Way have calculated the possible end of the universe. It is one of the greatest achievements of human curiosity. The universe may last trillions, quadrillions, or even googol years, but eventually, according to our best scientific understanding, the stars will fade. The galaxies will disappear. Black holes will evaporate. And the universe will fall silent. Yet for one brief moment in this immense cosmic timeline, the universe created something extraordinary. Life. And consciousness. Beings capable of asking questions about their own cosmic origin. Perhaps the most remarkable thing about the universe is not how it will end, but that for a brief moment it allowed us to witness its story. When even atoms cannot survive for most of human history. Atoms were considered the most stable building blocks of reality. Everything you see, planets, stars, galaxies, even your own body, is made from atoms. These atoms are built from smaller particles like protons, neutrons, and electrons. But according to some models in particle physics, even these tiny structures might not last forever. Certain theories suggest that protons, the particles inside atomic nuclei, may slowly decay. This idea is connected to something physicists call grand unified theory. If these theories are correct, then every proton in the universe has a finite lifespan. Scientists estimate that proton decay could take around 10 years or more. That number is so large it is difficult to imagine. But eventually, over unimaginable timescales, every atom in the universe may fall apart. Mountains, planets, stars, galaxies, everything that once had structure would slowly dissolve into elementary particles. Matter itself would vanish. The last structures in the universe before proton decay completely dissolves matter. The universe will pass through another strange stage. During this time, only a few kinds of structures will remain. Some white dwarfs may slowly collide and merge, forming rare flashes of light. Occasionally, wandering neutron stars might collide. These collisions would release enormous bursts of energy. But such events would become extremely rare. As space expands and galaxies drift apart, the distances between objects will grow larger and larger. Eventually, the universe will become almost completely empty. Not just empty of stars, but empty of nearly everything. The temperature of nothing today, the universe, has an average temperature of about 2.7 degrees above absolute zero. This faint heat comes from the ancient radiation left behind by the Big Bang, known as the cosmic microwave background. But as the universe continues expanding, this radiation will stretch and cool. Over trillions of years, the temperature of space will approach absolute zero. Absolute zero is the lowest possible temperature in physics. At this temperature, particles have almost no energy at all. In the far future, the entire universe will become an incredibly cold and quiet place, a cosmic desert where energy is almost impossible to find. Could intelligence survive? Some scientists have wondered whether an advanced civilization could survive in such a dying universe. Could intelligent beings find ways to adapt to the cosmic future? Some physicists, including Freeman Dyson, proposed fascinating possibilities that an advanced civilization might slow down its perception of time. By thinking more slowly, it could stretch limited energy resources over incredibly long periods. Other ideas suggest civilizations might migrate closer to black holes to extract energy. Some theories even propose harvesting energy from proton decay itself. But even the most advanced civilization imaginable would face the same ultimate problem. Eventually, energy sources would disappear. The universe would become too cold and too empty for any activity. In the very distant future, survival itself may become impossible. The age of stellar remnants. Once the last stars disappear, the universe will enter a strange new era. An era filled with the remains of dead stars. These remnants include objects like white dwarfs, neutron stars, and black holes. White dwarfs are the cooling cores of stars similar to the Sun. Over incredibly long timescales, they will slowly lose heat and become dark objects known as black dwarfs. Neutron stars are even more extreme. They are incredibly dense objects formed after massive stars collapse. A single teaspoon of neutron star material would weigh billions of tons. But the most mysterious remnants are black holes. Black holes are regions of space-time where gravity becomes so strong that nothing can escape. Not even light. At the center of most galaxies lies a supermassive black hole. The one at the center of the Milky Way is called Sagittarius, the asterisk. These cosmic monsters will dominate the universe for trillions upon trillions of years. But even black holes have a secret. They slowly lose energy, and eventually they disappear. The black hole era in 1974, physicist Stephen Hawking made a groundbreaking discovery using quantum physics. He showed that black holes are not completely black. They emit tiny amounts of energy, known as Hawking radiation. This means black holes slowly evaporate over time. But the process is extremely slow. A stellar mass Black hole could take 10 years to disappear. Supermassive black hole could take 10 years. That is a number so large it is called a googol. During this era, black holes will be the last major objects left in the universe. They will drift through empty space like cosmic ghosts. Occasionally they may collide and merge, forming even larger black holes. But eventually, even these giants will fade away. The final era of the universe after the last black hole evaporates. The universe will become almost completely empty. Only scattered particles will remain. Electrons, photons, neutrinos. The universe will reach a state scientists call heat death of the universe. In this state, energy is evenly spread out across space. No temperature differences exist. Without energy differences, no work can be performed. No stars can shine. No life can exist. The universe will become a vast, cold, silent expanse approaching absolute zero. Time will still move forward, but nothing meaningful will ever happen again. Part 7, a terrifying alternative ending. However, some scientists believe the universe may end much more dramatically. According to certain models of particle physics, our universe may exist in what is called a false vacuum. If this is true, the universe could suddenly transition to a more stable state through a process known as false vacuum decay. If such a transition occurred, a bubble of new physics would appear somewhere in the universe. This bubble would expand at the speed of light. Everything it touched would be instantly destroyed. Atoms would cease to exist. Matter would collapse. The laws of physics themselves could change, and because it travels at the speed of light, we would never see it coming. Part 8. The mystery beyond the end. Despite these predictions, scientists still face a profound mystery. What happens after the universe ends? Some theories suggest the universe could collapse back into a singularity in an event called the Big Crunch. Others propose the possibility of a cyclic universe where new Big Bangs occur repeatedly, and some physicists believe our universe may be just one bubble within a vast multiverse. If that is true, the death of our universe may not be the end of everything. It may simply be the end of our cosmic chapter. Final ending. Powerful closing. Right now, the universe is alive with stars, galaxies, and cosmic wonders. But in the unimaginably distant future, the universe may become silent and dark, a place where nothing moves, nothing shines. And nothing ever changes again. The universe began with a brilliant explosion of energy and light, and someday it may fade quietly into eternal darkness. Yet one mystery remains. Why did the universe exist at all? And why did it create us to witness it? Part 9. The era of particle decay. Even after the last black hole disappears, the story of the universe may still not be over. For an unimaginably long time, tiny particles will continue drifting through space. Electrons, photons, neutrinos. But, according to some theories in particle physics, even matter itself may not be permanent. Atoms are made of protons, neutrons, and electrons for decades. Scientists believe protons might last forever, but certain models of grand, unified theory suggest something disturbing. Protons may eventually decay. If proton decay exists, it means that every atom in the Universe has an expiration date. Scientists estimate that proton decay could take around 1 to 10 years. That number is far beyond human imagination. But eventually, every atom inside planets, stars, and galaxies could slowly fall apart. Matter itself may dissolve into radiation. If this happens, the universe will slowly lose the last traces of structure. Everything that once existed, stars, planets, life will dissolve into a sea of elementary particles. Part 10. When time loses meaning as the universe ages further, something even stranger happens. Time begins to lose its meaning. In our everyday experience, time is defined by change. Clocks tick. Stars move. Planets orbit. But in the far future, when the universe reaches near-perfect equilibrium, almost nothing will change. This leads to a disturbing philosophical question. If nothing changes, does time still exist? According to thermodynamic arrow of time, time flows forward because entropy increases. Entropy is the tendency of systems to move from order to disorder. But once maximum entropy is reached, there is no more direction. The universe becomes a timeless, frozen system, not because time literally stops, but because nothing happens to mark its passage. Part 1.1. The loneliest future. Imagine a conscious being existing in that distant future. Universe with no stars, no galaxies, no light. Only darkness stretching infinitely in every direction. In such a universe, even finding energy to survive would be nearly impossible. Any civilization that somehow existed trillions of years from now would face an extraordinary challenge. They would need to extract energy from extremely rare sources, perhaps from decaying particles or tiny temperature differences in space. But eventually even these sources would vanish. The universe would become too cold and too empty for any form of life. This leads scientists to believe that life in the universe has a limited window of opportunity. And that window may already be closing. Part 12. The possibility of the Big Rip, but the universe might end in a much more violent way. Some cosmologists believe dark energy may grow stronger over time. If that happens, the expansion of the universe could accelerate beyond control. This scenario is known as the Big Rip. In the Big Rip scenario, the expansion becomes so powerful that it begins to tear apart galaxies. Then star systems. Then planets. Eventually even atoms themselves. The timeline might look something like this. Billion years before the end, galaxies begin to break apart. Millions of years before the end, solar systems become unstable. Minutes before the end, planets disintegrate. Fractions of a second before the end, atoms are ripped apart. Space itself tears. Universe ends in an ultimate cosmic catastrophe. Part 13. Could the universe restart? Despite these terrifying possibilities, many physicists believe the universe may not end permanently. Some models suggest the universe could eventually collapse into a dense singularity again. This process is known as the Big Crunch. If that happened, the entire cosmos would shrink back into a tiny point of infinite density. And what happens next is one of the greatest mysteries in physics. That singularity might trigger another Big Bang theory. A new universe could be born. If this is true, Our universe may simply be one cycle in an endless chain of cosmic rebirth, a universe born from the ashes of a previous one. Part 14. The multiverse possibility. But there is another idea even stranger than a cyclic universe. Some physicists propose that our universe is only one of many. This concept is called the multiverse dot. In this model, countless universes exist beyond our cosmic horizon. Each one could have different physical laws, different constants, different dimensions. Some universes might collapse quickly, others might expand forever. Some might contain life far more advanced than anything we can imagine. If the multiverse exists, then the death of our universe would not be the end of reality. It would simply be the end of our universe's story. Asterisk. Part 15. Humanity's place in the cosmic timeline. We think about the lifespan of the universe. Something incredible becomes clear. Humanity exists extremely early in cosmic history. The universe may live for trillions, quadrillions, or even Google years, yet intelligent life appeared only 13.8 billion years after the beginning. In cosmic terms, we are living near the dawn of time. Future civilizations, if they exist, could experience a universe far older and stranger than the one we see today. They may witness the final stars fading from the sky. They may study the last black holes evaporating. They may watch the universe slowly approach eternal darkness. For billions of years, the universe has been a place of extraordinary beauty. Stars ignited in the darkness. Galaxies formed vast cosmic cities of light. Planets were born from clouds of dust. And on one small world orbiting the sun, something remarkable happened. Life appeared. Over millions of years, that life evolved, until one species began to look up at the sky and wondered. We discovered galaxies beyond our own Milky Way. We learned that the universe began with the Big Bang, and we even started predicting how everything might end. According to modern cosmology, the future of the universe may be unimaginably long. Stars will slowly fade. Galaxies will drift apart. Black holes will eventually evaporate through Hawking radiation. And trillions upon trillions of years from now, the universe may fall into silence. A dark, cold cosmos where nothing moves, nothing shines. And nothing ever changes again. But here is the extraordinary part. Right now, we are living in the brightest era of the universe, a time when stars still shine. Galaxies still collide, and the cosmos is full of light. In the vast timeline of the universe, this moment is incredibly rare. A brief window when the universe is alive with energy, beauty, and discovery, and somehow we exist within it. Tiny beings on a small planet, yet capable of understanding the fate of the entire cosmos. Perhaps that is the greatest mystery of all. Not how the universe will end, but how a universe of atoms, gravity, and energy created minds capable of asking why it exists. And maybe one day, somewhere in this immense universe, another civilization will look up at their sky and ask the same question. Until then, the universe continues its story, a story written in stars, a story that began with light and may someday end in darkness. But for now, the universe is still shining dot, and we are here to witness it.